Hello and welcome. In this video, we will be solving systems of linear equations, but we're going to be focusing on these special cases, okay? So this is kind of a continuation of our solving system series. In the first video, we solved by graphing. In the second video, we solved algebraically. If you haven't watched any of those, make sure you check them out. I will put a link in the description below to each of those videos. Now, special cases. Now, this is when we are either going to have no solution or when we have infinitely many solutions, all right? So those are our two special cases. Now, we already saw how that happened when we are graphing systems of linear equations. No solution occurred when we had a pair of parallel lines, whereas infinitely many solutions occurred when it was the same line on top of one another, okay? So graphically, you can see those very, very easily. However, it might take a little bit more work when we're solving algebraically. So I want to take a look at a couple of problems now to kind of point out what you are looking for. Okay, so we have an example here. So I have this system, 6x minus 3y is equal to 9, and negative 8x plus 4y is equal to 16. Now remember, when we're solving algebraically, we're thinking, am I going to use substitution? Am I going to use elimination? And technically, you can use either one anytime. It does not matter. It's just that sometimes one way might be easier than the other. So I'm looking at the system, I'm going, okay, I don't have any coefficients that are the same for x and y. Like if I added these two equations together, nothing would cancel out. So maybe not elimination yet. I'm also looking for substitution. Is it easy to solve for any variable? Well, it might not look that easy, but I'm looking at actually both equations, and in both equations, y would be pretty easy to solve for without having any fractions. Because if I'm looking here, like for example, in the second equation here, I'm looking and I see 4y. Well, if I solved for y, I'd have to eventually divide by 4, and 4 goes into negative 8, and 4 also goes into 16. What that means is when I divide by 4 to solve for y, I'm not going to end up with any fractions. So I'm going to go ahead and actually use substitution. Remember, I am a little biased for substitution. So I'm going to go ahead and solve for y. And I'm not going to kind of walk you through. I'm actually going to kind of speed this up because we already went over how to solve this in the previous video. So I'm just going to go ahead and solve this very quickly. Okay, so I went ahead and solved for y in the second equation. You could have done it in the first as well. I chose the second just because I didn't have a negative on the y. So I ended up getting y is equal to 2x plus 4. So what I'm going to go ahead and do now is I'm going to substitute that into the first equation for y. All right, I'm going to go ahead and do that kind of in a fast clip. So I went ahead and substituted in 2x plus 4 in for y in the first equation, and now we can go ahead and solve. So remember, I'm going to go ahead and distribute the 3 here. So this is going to become 6x minus 6x minus 12 is equal to 9. And now I can go ahead and I can simplify the left-hand side. I have some like terms that I can combine here, okay? So remember, when we use substitution, we do that so we can get everything in terms of one variable so I can solve for that variable. There's only one issue here. If I combine like terms here, 6x minus 6x, they cancel each other out. So all I'm actually left with on that side is negative 12. And I get negative 12 is equal to 9. And that's just simply not true. So this is actually when a special case happens. Special cases happen whenever our variables cancel out. So anytime all your variables cancel out, that's when you have a special case. The first scenario is all your variables cancel and you're left with a true statement. 4 equals 4, 5 equals 5, negative 10 equals negative 10. Those are all true. That would be an infinitely many solution. That would represent two of the same lines lying on top of one another, overlapping, okay? But that's not what we have here. What we have here is negative 12 is equal to 9, which is just simply not true. So when all your variables cancel out and you're left with a false statement such as this, you actually have no solution, okay? So this is an example of a no solution. If you were to solve both of these equations for y and get both of them in slope-intercept form, you would actually see a pair of parallel lines. Both of them would end up having the same slope of 2, but different y-intercepts. And if you graph both of them, you would notice that they would absolutely never intersect. And remember, a solution to a system of equations is where the lines intersect one another. And if they don't intersect, it is no solution. So this is an example of a no solution. Every variable canceled out, we are left with a false statement, okay? So that's an example of a no solution. I want to go ahead and take a look at a new example, and this one will be an example of infinitely many solutions. Okay, so we have a new system here. We have negative 6x plus 2y is equal to 2 and 3x minus y is equal to negative 1. Now, once again, I'm thinking about which way I want to solve this. Do I want to use elimination? Do I want to use substitution? And once again, I'm going to use substitution. You could use elimination. I'm just very biased towards substitution. So I am looking at this and I'm going, okay, solving for y in this second equation looks very easy. So I'm going to go ahead and do that. So give me just 1 second and I will solve for y. All right, so we have y solved for. I ended up getting y is equal to 3x plus 1. And now what I can go ahead and do, since I know that y is equal to 3x plus 1, I can take that once again, remember, and substitute it in for y in the other equation. So that's exactly what I'm going to do. And now I'm going to have negative 6x plus 2y. Well, remember, y is 3x plus 1. Okay, 3x plus 1. Is equal to 2. So I plugged in 3x plus 1 for y in that first equation. And now I'm going to go ahead, I'm going to solve. I'm going to distribute that 2 into that quantity of 3x plus 1. And that gets me negative 6x plus 6x plus 2 is equal to 2. And once again, I have some like terms on the left-hand side. So I'm going to go ahead and combine those, negative 6x and positive 6x. And now when I add those together, when I combine like terms, once again, they end up canceling. So I'm going to be left with 2 is equal to 2. Now remember, in the previous problem, all the variables canceled and we were left with a false statement. It was negative 12 equals 9, I believe. That's not true. So that was an example of no solution. No matter what you plugged in for x or y, it was never going to work. However, in this problem, we ended up with a true statement. All the variables canceled, but we are left with a true statement. 2 is equal to 2. Now, this is an example of infinitely many solutions, which I'm going to abbreviate to IMS. This is an example of infinitely many solutions. Not all real numbers, infinitely many solutions. There's a key difference here. All real numbers would imply you can plug in any numbers for x and y, and it would always work, which isn't the case here. It would only be the ordered pairs of x and y that are actually on that line that would end up working, okay? That's the difference between all real numbers and infinitely many solutions. So this one would be infinitely many solutions because we actually have the same line of y equals 3x plus 1. If we solved for y in the first equation, we would get the exact same 3x plus 1 equals y, which means it's the same line on top of one another. So that's why it's infinitely many solutions, okay? So I hope this video was helpful. In the next couple of videos, we're going to be graphing systems of linear inequalities, and we'll also be covering 3 variable systems. Well, we're no longer talking about 2 lines intersecting each other. We're talking about entire planes intersecting each other, which is actually super cool. I hope this video was helpful. If you have any questions, feel free to let me know. And until the next video, I see you next time.